Hello, good morning, sir.
Yeah, good morning, Rakesh.
Yes,
Am I
sir.
audible? Am I
Yes,
audible?
sir.
Okay, thank you. And my video, from whether I am
Yes, sir.
audible.
Video is also coming.
Okay, thank you, thank you. ठीक है, thank you.
Okay.
अच्छा लगा।
Good morning, sir.
Good morning, sir.
Very good morning, one and all. I welcome you all on the third day of AICTE sponsored ATAL FDP, organizing at NIT Kurukshetra. Here we are having Professor Narendra Kumar from NIT Jalandhar, one of the known, well-renowned expert in the domain of additive manufacturing. So we are just waiting for few more participants to join so that we will start the session on time. Means by 11:30 it will be started. So just wait. In couple of minutes we are just going to start. We are going to have a very fantastic session here. Thank you. Yeah, so I think sufficient.
Yes, Dr. Ravi, good morning.
Yeah, very good morning, Professor Narendra. How are you?
I am fine, sir. What about you, sir?
I'm well, all well here, sir. We are very great here at NIT Kurukshetra. I hope that at NIT Jalandhar you are also doing great.
Yeah, sir. Thank you.
Yeah, so I think so. We can start if we permit.
Yes, sure.
Yeah, so dear participants, our session expert here, Professor Narendra from NIT Jalandhar, has already joined us. So without wasting any single minute further, I'm just would like to just share some brief about Dr. Narendra before requesting him to deliver his talk here. So Dr. Narendra Kumar currently holds the position of Assistant Professor Grade 1 in the Department of Industrial and Production Engineering at Dr. B.R. Ambedkar National Institute of Technology, Jalandhar, Punjab. He is a recipient of prestigious IEI Young Engineer Award in recognition to his contributions to the field of production engineering, as well as he has also been awarded Best Teacher Award in 2024 at NIT Jalandhar. With over 12 years of experience in both research and academia at undergraduate and postgraduate levels, he has established himself as a seasoned academician. He has also secured funding of about 4 crores for pursuing research on 3D printing, 4D printing from ISRO, DST, BIS, FIST, etc. Dr. Kumar earned his bachelor degree from UPTU Lucknow, and he has pursued his master's and doctorate degree in the domain of additive manufacturing from IIITM Jabalpur in 2018. His doctoral research focused on the development and performance evaluation of pellet-based additive manufacturing processes for flexible parts. Prior to his current role, he has also served as assistant professor in the Department of Mechanical Engineering at BIT Verda. He has also served as a position of research associate at IIITM Jabalpur under the sponsored project by DST AMT. His focused areas are related to the CAD communication, rapid prototyping, tooling, additive manufacturing, material development, 4D printing, and at present he has published more than 80 research articles in the various international and national journals of repute. He is also having 4 different patents into his account. And very vast experience Dr. Narendra is having, and there is a lot to share about Professor Narendra, but as the time constraint, I'm just handing over this session to Professor Narendra. Sir, you are welcome.
Thank you, Dr. Ravi. Thank you for this opportunity. It's very surprising to me after me seeing the chat box. One participant asking for feedback link. Yet I have not delivered my talk.
Yeah, they are more curious about I think feedback. They want to give their feedback at the very early.
Okay, sir. So thank you. Let me begin
Yeah.
with my
Yeah,
lecture.
please, sir. Definitely. Please continue.
So, sir, okay, let me share my screen with my.
Yes. I will confirm you, sir. No issue. Please share. I will confirm your audibility as well as the visibility of your slides.
So, Dr. Ravi, can you see my screen?
Yeah.
Confirm.
It is very clearly visible to us, and you are audible also. Please go ahead.
Okay, sir. Thank you. Thank you for confirmation. So, dear participant, good morning to all. Today, I'm going to deliver a lecture on the topic of CAD modeling and STL manipulation. And I have chosen this topic because of the title of this FDP. Because FDP is based on the additive manufacturing of the biomedical applications, right? So for these applications, we have to make the CAD models, which are very complex in nature, and they may have curvature, right? So during the transition from CAD model to STL file, the model or the file may have the errors, right? So that's why STL editing and manipulation sometimes is required. So what I'm going to do today, I'm going to give you a brief idea about the CAD modeling that can be done with the help of open source software, right? And then I will be talking about the STL editing and manipulation using the, again, open source software, right? Although some, commercial softwares are available in the market, but they are very costly, right? So that's why it's very important to understand about the capabilities of the open source software, so that you can do the CAD modeling as per your requirement, and on the same hand you can go for the STL editing and manipulation. So this is my small outline of my presentation, where I'm going to talk about the 3D printing process chain, and I will be talking more importantly on the software part, right? So then I will be discussing the features of FreeCAD. So some disturbance is coming, so please mute yourself. I think somebody has unmuted, so please, I request you, please mute yourself.
Okay, sir, I'm managing
so
a participant, maybe some. No issue, sir. I will manage.
okay, sir. And then the second software, that is Meshmixer, right? So this software is basically the STL repairing package. It provides the package for STL repairing. So I will be briefing more with this particular software. Okay, so let me begin with the 3D printing processing. So I think it's a third day of FDP. So now you have some basics of 3D printing in your mind, right? But still, let me tell you what is the process chain of 3D printing, right? So process chain basically started with the CAD modeling. Then in the next step, we convert this CAD model into the STL file. But nowadays it's not essential to convert into STL file, because other formats are also available. So CAD model and then STL file. Then we go for the slicing, and then we go for toolpath generation, and finally we fabricate the part as per the given instructions. Then the last stage, if post processing is required, then we can go for the finishing, we can go for the coating, we can go for the coloring, etc. So this is the the process chain of 3D printing, by which you can make any part from its CAD model, right? So during these steps, where is the use of software? So obviously, for very first step, that is CAD modeling, we need to use software, right? So this is step one, and step two is the step two is STL. So again, STL, most of the people who are working in this area, they are not aware with the STL editing. What they do, they make CAD model, and then directly they convert CAD model into STL file, and they jump for the slicing directly into the slicing software, right? Because those people do not have the idea whether the STL file can be modified or not, and also why modification is sometimes important. So today you will realize the this thing, why STL important. Why STL editing may be important in some of the cases, right? And why we should always check the STL file for the error, right? And third step, basically where we use software, that is for the slicing and the toolpath generation. So I will not delve into the slicing and toolpath generation through the software, but it's basic. So you can use the slicing software like Cura, okay, to just get the information about slicing and toolpath generation. Today I will be talking about only the CAD modeling and tessellation, or the STL manipulation, right? In detail. So now let me show you the software packages which are available for the use in 3D printing domain. So here I have summarized some of the CAD modeling packages. like in both the categories, in the open source category and the commercial category. So in this open source category, we have FreeCAD, we have Google SketchUp, we have OpenSCAD, right? Other software is also available. Tinkercad is there. But when I talk about the commercial softwares, right? Here we have the CATIA, Creo, SolidWorks. So Fusion 360 is also very popular. SolidWorks is very popular, and CATIA was very popular, 10 years back, right? And Proi, nowadays it is known as Creo, right? 10 years back, CATIA and Proi, they were on the top in the commercial category. But now SolidWorks has also, has some place in this category. And if I talk about the slicing STL repairing packages, under the open source category, we have Meshmixer, we have MeshLab, right? And under commercial category, we have the NetFab with Fusion 360 and Magix from the Materialize. It is also very popular. Okay. So out of these softwares, I will be going to talk about the FreeCAD, and this Meshmixer, right? From both the categories. And this category I'm not going to discuss, right? So you can explore this Cura because it is very common software nowadays, right? Slicer is there. So these are freely available and they are also compatible with the most of the 3D printer. You can select your own 3D printer from the list, right? As per the availability, and then you can use them as per your requirement. You can feed parameters you like layer thickness, angle, pattern, temperature, contour. So these things you can select under by using the software. So I'm not going to detail right much. So you all know CAD modeling is the essential step, right? Because as per the definition of 3D printing, it is a process by which we can convert the CAD model into reality, right? If you have any idea, right, in your mind, what first step is to convert that idea into CAD model, right? Then CAD model to physical model. So CAD model is very essential part. If you go into the market, right, you will find the various software as I have mentioned in my previous slide, right? So here I will be discussing about this FreeCAD. It is open source parameter 3D CAD modeler, right? So here I will stop my presentation. I will directly switch to the software part. So here now I have opened my software. Okay, this is at bottom. You can see that here I have opened the FreeCAD software. So when you open it, this kind of window will be opened. Right? And it will ask about the which theme you want to keep, light theme or dark theme. So here I have chosen this light theme, okay, because I like it. So and I can also select language, okay. So based on my knowledge, I can select the language. I can also select unit system. I can also select the navigation style. So what is the meaning of navigation style? If I select the Open Inventor or Blender, right, the setting of my mouse will be changed. So suppose I am the existing user of any software, right, and I want to keep the same setting for my mouse, I can easily select that particular software from the list. So suppose from here, what I have done, I have chosen this Tinkercad. So now my mouse setting will be same as the Tinkercad. So this flexibility is given in the software. So now what I'm going to do, I'm going to just select it. Done. So here you will find the the list of the activities, right, which can be carried out under this software. So for example, here from because my objective is to create a CAD model, right? My objective is to create a CAD model. So here what I will do, I will select this parametric part, okay, right? So once I click on the parametric part, it will open the another window, right? That will be blank and white, okay. And on the left side, there is the option to create a sketch. So when I move my cursor there, right, it is just showing the create a sketch, create a new sketch, right? So I will click on it. Now it is asking to select the plane. So in 3D printing, generally we do sketching or the CAD modeling in XY plane, because XY plane belongs to the bed build platform, right? So here I am going to select this XY plane, and then I will click on OK. So the window is quite similar to the SolidWorks, right? So once I click on the OK button, here other options will be appear on the top in the red color. So here if I move my cursor here, the message is create point. Second thing is the create polyline. And also there is another message, M key cycle behavior. So, and once you press the M key after selecting this, for example, this is polyline. So now I am drawing a polyline, right? Like this. So if I press the M button in between, you see what is happening. See, the behavior of this line is changing, right? So we can change its behavior, we can change its nature by just pressing the M button. So for example, this is my closed polygon, okay, which I have uh, drawn using this polyline command. Now, for example, let me tell you the dimensions, right? Because how we will do the dimensioning of this. So for example, this is my sketch that I want to make, okay, that I want to convert into the CAD model. So from the upper symbol, this symbol A, okay, or the angle symbol is there. So you can give the dimensions. So here you can see that for angular dimension, you can choose this. For the vertical dimensions, you can select this one. If you want to constrain the distance between two lines or the two entities, you can select the distance command. You can also constrain the auto radius and diameter, right? So for example, in my case, I have curvature also, right? And I have line also, right? So for curvature, I can constrain the curvature in terms of diameter or radius, right? So these things are there. Angle, if I want to suppose constrain the angle between the two lines, for example, let me select the constraint angle. Now this one and this one. So currently the angle is 82 degree, 82.56 minute. Okay. So now let me change it to 80, for example. Okay. Similarly, I want to give the angle between these two. I want to change it to 50. I can do it. And for example, I want to constrain the angle between these two to 120. So I can do it. Right. And also suppose I want to give the distance, for example, to 15, so I can do it. I also want to length of this line to 30, right? 55 and then 12. Okay. So in this way we can do the dimensioning of the sketch. We can constrain the parameters, sorry, entities. We want to fix their position, we can do it. So this software is very simple, right? And it is openly available. If you just write the FreeCAD, okay, here you can select on the first, you can click on the first link. So here now the current version is FreeCAD 1.0 that I have downloaded today itself. Right? So this is how we can sorry. This is how we can easily download it. So when you click on download button, the downloading is started. Now let me go back to the software. Yeah. So now suppose we have made this sketch. Okay, this sketch. Edit the sketch again, right? So let me close it first. Some disturbance is there. Ravi sir, please check. Some disturbance is coming. I don't know where from it is coming, but
Okay, I'm checking, sir. No issue.
so let me close it, right? And then again, when I close it, some new options are appeared on my screen, right? Previously on the top, I had the options related to the sketching, but now options are there related to the CAD modeling or the convert this sketch into 3D model. So here in the first left side, we have a pad command, right? Pad. So this is, I think, similar to the CATIA. There also we have the pad command, right? So in the pad, see, when I click on the pad command, what is happening? Now my sketch has been converted into 3D model, or we have given the thickness along the Z direction. Along the Z direction, right? So see what is happening. I can change its thickness, right? I can uh, change it to 5 mm. I can keep it to 50 mm also. I can directly write 50. So its thickness will be changed immediately. So again, I want to edit it. I can do it easily. Okay. So these kind of features are provided in this software that can be used for the CAD modeling. Okay. So now let me keep it to 10 mm only. Otherwise, it will be very weird in look. So yeah. Now if you see that my model has sharp edges, right, on the corners. So for example, suppose I want to give this fillet or the chamfer command. For example, I will use this. So I will pick this edge, this edge, this edge, this edge. So okay, so let me do the experimentation. So you can see the radius currently. Okay, and from here on the bottom I can use it for all the edges. See, when I click on the all edges, it will automatically pick all the edges, whether they are on the top or they are on the side or on the bottom. And suppose my interest is in the change this radius to 2 mm, 3 mm, 4 mm, 5 mm. Okay, so up to maximum it is taking only 4 mm, because otherwise it will not be possible for us. So for example, let me make this model. Okay, let me make this model. So now this is, for example, my CAD model. Now my objective was to prepare a CAD model for 3D printing, right? So now next step is to, can anyone tell me what is the next step? What I need to do now? Ravi sir, please allow participant to speak.
Sir, to prepare STL file.
Yeah, prepare the STL file. Very nice. Okay, so now what we will do? We will go for the STL. Okay, first let me show you one error actually that may come at the see what is happening. Select the objects to export before choosing export command, right? So because I have not selected any object, that's why it is not. But now I have selected this. So now when I go into the export command, what I will find, I will find the various file formats that can be selected. So here we have the 3D manufacturing format. Additive manufacturing format is also there. This is also becoming very popular nowadays, right? Because STL has many issues, so that I will be talking today. So let me select the STL from here. Okay, so here I think we have this STL mass. Can you see this STL mass? And in bracket we have the extension .stl. So let me give the the name. So what I am just going to give this NIT KKR, right? NIT KKR, and I will select this. Okay, now I will open my STL file, right? I will open my STL file in the, so this is my right STL file, and I will open it with the notepad. Can you read this? Can anyone tell me the meaning of this text? No, because we cannot read it. This is not human readable, right? This is not human readable, that's why we cannot read it, right? But now you can see the length. We have almost 19 lakh characters, right, into this STL file, single STL file. Now let me go back to my presentation. Okay, so what is my presentation? Again, this, up to this point we have discussed the features of FreeCAD. So now because we have exported the CAD model into STL file format, right? Now the file is ready for slicing, but before slicing I will check my STL file whether it is correct or not, whether it is accurate or not. So what is the meaning of accuracy? That we will understand, right? So in order to edit or in order to check the STL file or see the STL file, we can use Meshmixer. But before Meshmixer, I will give you brief idea about STL file. Okay, what is STL file, right? So you can see the difference in these two models. STL basically this stands for Standard Tessellation Language, and this file was the first file format, okay, of 3D printing, and it was used to move the 3D CAD model data into stereolithography machines, because stereolithography machine was first apparatus, right, in 3D printing category. But later on, okay, that's why it was known as SLA file, stereolithography file. Okay, STL file means stereolithography file. But now, because it has become a de facto standard and people are using it in other machines also, in other apparatus also. Okay, so that's why it has basically nowadays people are calling it the standard tessellation language, right? So it is accepted by almost all 3D printing systems, right? And you can see the difference in the uh, CAD model and STL file. So this is a simple cylinder CAD model, cylindrical CAD model, and when we convert this into a STL file, this kind of triangles, tiny triangles are used to approximate the surfaces. Okay, so it has, for example, the 1 and 2, 3 surface, right? One is circular one. So these surfaces have been approximated by using the tiny triangles, so that you can see the accuracy is reduced, right, when we are converting into a STL file. But one thing option is there that is not available with FreeCAD. We can change the quality of STL file while exporting it. We can select the parameter also, right? We can reduce this length, right? I can change the size of the triangles. In the paid commercial softwares, there is a provision to change these parameters. So during the export, we can also change the quality of STL file, and we can decide the number of triangles required to approximate the surfaces. You can see in the second model, even though you cannot count the triangles, this is a bunny model, right? That has been exported into STL file format. Now, if I ask you to count these triangles, you cannot count because they are in number thousand in numbers, right? So suppose if any triangle is missing, for example, if any triangle is missing, right, from this net, how you will identify it? Otherwise, there will be problem during slicing, right? So STL is nothing but the triangular representation of a 3D surface geometry, and here we just export the information in the form of the facet and the normal. So I'm not, because due to the time restrictions, I'm not going in much detail. So,
वो
but
भी नहीं जाएंगी शायद, क्या नाम है उनका, पर जाती हैं प्रभजोत मैम पिकनिक पे.
Ravi sir, please see if somebody is talking about the picnic, please.
Yeah, I have done, sir, no issue.
Okay, thank you. So here, if you see the variation in number of triangles for different geometries, because as I told you, some commercial softwares provide this flexibility. So to change the number of triangles, right? Overall dimension for the same object, you can change the number of triangles. So here I have taken the example of SolidWorks. So in SolidWorks, you can see the number of triangles. In this case, only 944 triangles are there, and in this, for the same geometry, here the number of triangles are only 8, but accuracy has been degraded. So It means that for curved surfaces, more number of triangles means more accuracy, right? And if I talk about the STL file type, there are two types of there are two formats. One is ASCII, that stands for the American Standard Code for Information Interchange, and second one is binary. And what are the difference between these two? ASCII is more descriptive in nature and it is human readable, but very large size. Binary, it is more common and compressed in size. So as I told you, ASCII is human readable. So the file which we have exported from the FreeCAD software, that is not human readable. It means that file is the binary STL file. Okay. If I convert that file into ASCII file format, the size of that file will be large in that case, but it will become human readable. Okay. So that this experiment you can carry it out in your system. You can just make any STL file in the SolidWorks or CATIA. You can export the STL file in ASCII and binary both to see the difference. What are the and open both the files in the Notepad. Then you will find the difference. You will find the difference between two file formats. So this is the a typical example of a ASCII file format, and here we have the example of binary STL file format, right? Now, what are the advantages of the STL file? Why people are using this file format in 3D printing domain? So the first advantage it's simple to understand and very simple to code, right? Because I told you that we can easily open the STL file format in the Notepad, right? Second thing is that it minimizes the computational overhead during the slicing. This is very, very important. That's why I have changed the font of this statement. It minimizes the computational overhead. How? Because it contains the triangles, right? So for example, the case of cube, only 12 triangles are there, right? 12 triangles. So slicing is the essential step of 3D printing because it's layer technology, layer by layer technology, right? Because we add material in the layered form. So in all the cases, in all the 3D printing cases, we have to slice the CAD model into the layers. So with STL file, it is very, very it is very, very what should I say, important, right? Because it minimizes the computational overhead. Because in slicing, what we do, we take a plane, right, and we get the intersection point of plane and the triangles, right? So suppose if we assume other than triangle, if we have any other polygon, for example, we have the small circles, right, or the some curved polygons or any other polygon. In that case, what will happen? We have to find out the intersection of plane and the curved line, okay, or the chord. So in that case, computational time will be increased and also algorithm complexity will be increased. So that's why it's uh, very popular, because triangles are ideal due to their planar nature, and they simplify the intersection computation. So this is, I think, one of the reasons that's why people are using it, and nobody is able to rid off from this file format. So as it has some advantages, it has also has some disadvantages, like long syntax is there, many times larger than the original CAD data, right, for a given accuracy parameter. Because if you do not maintain the parameters, right, of STL file, what will happen? You will not be able to capture the original CAD data surfaces, okay, accurately. So for the given accuracy parameter, if you go for the STL, obviously small triangles will be used there, or number of triangles will be more. So it will be very large in size, right? For the same, the original CAD data, and it carries much redundant information. How? Here I have taken one case, this one. So if you see, we have 1, 2, 3, 4 triangles, right? So when we export this data into STL file, what will happen? Okay, there is one edge, one common edge between 1 and 2. Similarly, between 2 and 3, and 3 and 4, and 4 and 1, right? So what is happening? What will happen when we export it into STL file? This information, this edge information, will be repeated twice. Similarly, this is also repeated twice, and this is also repeated twice, and this is also repeated twice. So in this way, you can see that it carries much redundant information, because already the edge information was there, but it is repeating, because due to its nature. Okay, duplicacy is allowed in the STL file, because STL writes the separate information for the given triangle. So here we have 4 triangles, so the information will be written 4 times, no matter whether it was already shared with the first triangle or not. So due to this,
एक बार
and
जाके
similarly,
आते हैं, करने का तो नहीं है, बट अभी एक्सपीरियंस
Ravi
करके
sir,
आते
please
हैं।
check.
Yes, I have muted her.
Participant, I request you, because it breaks my flow actually, right?
Participant, please don't unmute in between. Please take care. Our
Hmm.
experts are just devoting that much of support here, and still your disturbances are just impacting his performance. Please be careful.
So see, in this example, for this point, this is the common vertices, right? Vertice for the triangle number 1, 2, 3, 4, and 2 triangles at the bottom, right? So see, this common point is shared between 6 triangles. So this information also will be repeated 6 times. Okay, so this is, I think, the disadvantage. Other than that, there is no disadvantage or limitation of STL file. And also one more thing, nowadays people are interested in the color printing, color 3D printing. So it does not carry any color information. So for color printing, you have to go for the other file formats, right? You have to check which format is capable to have the color information. Okay, so that you need to check. Okay, but STL does not carry any color related information. So here you can see the parameters, okay, that can be controlled. So I'm not, because of the time constraint, I'm not just covering these aspects in detail. But here you can see the size, difference in the size, more accuracy, more size, right? High size. So you can see in the first case, the file size is 705 KB, but you can see the surface, it is very rough. In the second case, the size is 2760 KB. Again, the size is not that much smooth. So that's why I told you that for the given accuracy parameter, right, the file size is increased. So that's why in this case, it become very smooth, right? From the neck die, you can see the smoothness of this model, and the size from 705 kV to it has now changed to 17,350 kV. So this may be more than the original CAD file, because in this case we have to use small triangles, then only we can capture the curvature of the spherical CAD model, right? So this is how we can change the parameters. So for the accuracy, you can play with the parameters. Okay. So there are many reasons for bad STL file. So that I am not covering in detail, right? I will share this this presentation with all of you, so you can go through these errors, right? What are the meanings of these errors? Now directly I'm going to the software part, right? Suppose if any error is there or any hole is there, any puncture is there, how can you rectify? How can you uh, what should I say? How can you just repair your STL file, right? So here I am giving you some of the cases, right? So these are the errors, okay? Some overlapping facets are there, some of the edges are overlapping each other, some cell problems are there. Okay, now now let me just go to the Meshmixer, okay? So here I have what I've done, I have opened the this Meshmixer window. So this is the user interface of Meshmixer, where you will find the some options on the left side and some options on the center of the screen, and some file related options on the tab on the top, feedback, help. Although the Autodesk has discontinued this version of Meshmixer, right? They are not updating this because they are promoting their next, the NetFab with Fusion 360. They are promoting this one because this is commercial one, right? But its educational version is free. So, but they have discontinued this software, but still it has a lot of feature that can be used to. Okay, now let me import my file, the file which I prepared, right? Where is it? Yeah, this one, NIT KKR. So this is my file. So you can see that, you can see the triangles, right? I'm zooming it, right? I'm zooming it. Now you can see the triangles. Can you see the triangles? Now can you see the triangles, Ravi sir?
Yes, yes. Participants are writing in the chat box. They are saying yes, they are able to see.
Okay, so you can see because my model has the curved surfaces on the top, sorry, on the edges. Sir, lecture ले रहा हूँ मैं. हाँ, ठीक. Okay, so and wherever I am having the flat surface, the triangles, number of triangles are less, right? See, so on the curved surfaces, okay, to approximate the curved surfaces, we have to increase the number of triangles, right? So just for example, here we have the curved surface, and we have more triangles, right, in this region only. So triangles are varying, right, in number depending on the type of the surface, whether it is flat or curved surface. Now, for example, I want to edit this. Okay, I will check first of all, what I will do, I will check my model, right? I will analyze my model whether it is having any kind of problem or not. Okay, so when I inspect it, I does not find any kind of error into this because it is closed model. But for example, deliberately what I will do, I will delete these triangles. Okay, now you can see the hole. Can you see the hole into the STL file? Deliberately I have deleted this patch, this triangle from my STL file. So now I can see inside of my STL file, right? I can see inside of my STL file because of this hole. Now again, I will inspect the STL file, right? It is showing that it is having the problem, right? See, what happened? What happened? Because I have taken I have selected this option, flat fill. That's why this curvature has been deteriorated. See, now it has become flat. Okay. So instead of going to flat fill, I will go for smooth fill. Now it has filled the file smoothly, right? Smoothly. See, from the side also. And let me first let me change this. Okay, sorry. Under view platform, where is it? Yeah, grid I have removed. Actually, it was hindering the view. Right now, it has again there is a problem. Right, when I use the inspector command, still there is a problem with my STL because here I am having the missing information, right? Although it is closed, but it is having some sort of error. So in that case, I can go for the brush. Okay, so I can, okay, I think it has, see what is happening. Let me reduce the size. So this was the case, and from here I have chosen this. See, it is smoothing the STL file now. It is increasing the number of triangles. See, earlier I am smoothing my STL file, right? See, triangles are changing, number is changing, right? And now my STL will become very smooth. So with the help of brush, what I am doing, I am smoothing the STL file. So now can you tell me the number of triangles in my STL file? Can anyone see the number at the bottom, right? it is approximately 28,898. So as I am using this brush, those triangles, now it has become 30,119. Now it is become 30,288. Okay, because as I am smoothing my STL file, it what is doing? It is increasing the number of triangle and it is increasing the accuracy of the STL file. See, now the triangles are 65,000, sorry, vertices are 32,550. Triangles are 65,096. Sorry for the error. Now triangles are, suppose I want to smoothen this surface. Okay. Now the triangles are 68,194. Similarly, suppose I want to smoothen this part, right? Okay. So that in this way you can edit your STL file, or if any error is there, you can repair your STL file, right? So suppose this is also left, this region also left. I will also smooth this region. Okay. So now my file is very smooth and very accurate. I can change parameter from here. Okay. Okay, so in this way you can modify your STL file. For example, now I want to cut my STL file into two parts. For example, let's say I have dual 3D printer and now I want to, for example, make the part by using two different materials, right? So here from I will cut my STL file and STL file, and you can see that now here we have some options like no fill, minimal fill, remesh fill, fixed fill, right? So remesh fill means, because as I will cut this STL file into two parts, so obviously we will have two holes. One is in the upper part of the STL, and one is the second one is in the lower part of the STL file. Right. So here, okay, let me show you first, right? Initially, I am using this no fill. Okay. Now what is happening? Now you can see this is not closed at all, right? And the bottom portion has been disappeared. Why? Because here we have selected cut discard half. But from here, if I suppose select the key, okay, first let me show you the no fill and the remesh fill. Now again, because I have chosen the remesh fill, that hole has been filled by software, right? By software itself. But earlier, because I did not choose the option, so that's why here we had the hole. So here what I'm going to do, I'm going to just keep both the parts, right, with me, because I have to print both the parts by using my 3D printer with dual material. So I will keep both the parts, but here we can see the parting line. There is small thin line is there, right? That is indicating the plane, okay, where from we have cut the STL file. So if you select this STL file, okay, because I have clicked twice on my CAD STL file format, the color orange color is indicating the selection. Okay, my selection. So now because it is cut it into two parts, okay, two halves. So now only this much portion is selected only by the command. For earlier, when I was using the same command, right, it was selecting the whole part. So now I can easily I can easily export this upper part into STL file and also lower part into the STL file separately. So separate two STL file will be exported for dual printing, right? So this is how we can just now let me show you some other feature of this. So to show other features, I will replace the part with the bunny. Sorry. Where is it? I think it is in the Meshmixer library models. So for example, I have imported this model, okay, bunny model, and here if you see that this model is also having the hole at bottom because we can see inside of the STL file. So what I am going to do, I am going to inspect my STL file first. So it is showing the inspect and repair mesh defect, right? Inspect and repair. So this blue balloon actually is showing the boundary of the hole. So here from I have chosen this flat fill because I want to.
Dr. Narendra, sorry to interrupt. I think your slides are not visible now. Please check.
Sir, I have not changed my setting yet.
Okay.
Let me check
Maybe
again.
due to some network issue and all. So
No.
I think
Now tell me, sir. Now tell me, sir.
yeah. Now it's coming.
Okay.
Thank you.
Okay. So you can see that. Okay. So participant, can you confirm whether my slides were visible to you or not? Because
Yes, it is visible.
again I will repeat. No, now it is visible, but earlier.
Not earlier, it is not visible.
So why you not informed me? Actually, you should have informed me.
Actually, they have
first,
written in
because-
the message box actually. So that's why I read that for you. Please.
Okay. Thank you. So see, actually, okay, let me show you again. Okay,
It
so
is
this.
again gone. It is again gone, Mr. Dr. Narendra.
Huh?
Earlier it was
How
there,
is it
but
possible? Because I don't know, Professor, what is happening, but from my side there is no issue.
okay. Yeah, now it's yes. Now it is coming again. Yeah, now it's coming. Yeah, no issue.
So please inform me, okay, if you find any issue, right?
Definitely.
If you face any difficulty in my slide visibility, please inform me, okay? So since, okay, see, you can see this is the CAD model, or you can see the STL model of this bunny. So if I go in the analysis or the inspector command, it is showing the again the same options, flat fill, because this is the bottom part. I want to keep my the surface flat. So now see.
Again, slides gone.
Oh, what is happening? Slides gone. So somebody is doing anything, or it is problem from my side, because I'm not doing anything, right?
Yeah, it may be some that network
Even
interruption.
in your,
Actually, it is
because I'm
gone for
not.
all. Actually, it is we are unable to see and our participants also. So
No,
I
no,
think there is
no,
some
it's
issue.
okay. I will do it again.
Sir,
But
one
sir, I have
participant,
not.
me, Bhattacharya, again share the content. That's why the problem is creating.
Ask him do not interrupt in between. Otherwise, I will not be able to
Yeah,
complete
please,
this content.
whatever the Gaurav said, please take care. Do not try to share your screens and all. Otherwise, we have to remove you because we can't just interrupt during the sessions. Please don't force us to just be like that. Please. Thank you for your support.
Okay, so see here we now it is visual now. Professor Ravi.
Hani sir, yes sir.
Okay, thank you. So see now you can see that here in this object we have the hole, so that I'm going to fill with the flat fill command, and here once I press the auto repair all, now you can see it has been filled, right? And it is also having the triangles. It means the surface that has been created also has been converted into STL file, right? So how you can see how this Meshmixer can help us in the repairing process. Okay, let me show you a very important feature of the Meshmixer. So for example, let me show you. Suppose I want to modify. Suppose I have downloaded one STL file from the internet, because nowadays some websites are available which offer the ready-made STL files, right? For example, if you search on internet, for example, Taj Mahal STL file, for example, let's say, or Ayodhya Ram Mandir, Ram Temple, right? You will find many STL files. So, for example, you want to print them, right? You want to print them for your application. So, and somebody has written his or her name on the STL file. Okay, upload STL file, and now you have downloaded it. Now the question is how you will edit that STL file. Okay, how you will be able to edit that file, or you will suppose you want to modify that file. How can you do this? So then Meshmixer we have many options. For example, it's called- okay, one thing I will actually want to show you. For example, I have deleted these, these triangles only, right? Now it is, you can see there is a hole in the STL file. Okay. Now, for example, here we have a zipper edge. Another command is there, zipper edge. So here, if I zip means zip, it will zip the hole. See what is happening. See what is happening. So manually, suppose if you want to fill any gap, so that option is also available. Or sometimes you want to refine the mesh. Refine means, again, for example, here the triangle size is too large, for example, and I want to refine it. So in this selected area, you can refine the mesh, right? You can reduce the triangle size, you can enhance the accuracy, right? So this is how Meshmixer. Now you can see the difference, right? In the area where I have used the refined mesh command, the mesh has been refined. The triangle size has been reduced, right? But the area where I have not used this command, the area is as it is, right? Sorry, the size is as it is. Okay. So this is how you can refine the STL file. And okay, one more thing that is also very interesting. Okay, I will be going to cut this STL file, right? So for example, For example, here I have cut my STL file. Now what I'm going to do, I am going to delete this part. Okay, I have deleted this part, and I want to modify this head with for example, let me say this camel head. Let me take or let me take this one. Okay, let me take this one, and also let me change the size. I can change its position manually. I can, the right, yeah, from here I can easily guess the position. Oh, I don't know what happened with the software. So okay, this was my STL file, right, that I have cut it down, and now I have added this from front, and I have changed the size from here, right, and I also want to change it now. Okay, is it fine? Okay, now I think it is fine, right? Accept. So during this process, right, during this process, what has happened? Here we have some flat surface, this flat surface. Although there is no problem with STL file, there is no hole, right? But there is a problem with the STL file, right? So I will try to re-smooth it. I will be using this command again, because this will smooth the edges, right? This will smooth the edges, and it will also help in the smooth transplant of this head into the virtual transplant, right, not actual one. So smoothly you can do this process, right? You will never see any kind of joint or any kind of abstraction in this process, because as we are using this command, right? So see how the whole STL file is getting repaired.
Dr. Narendra, screen is you, please.
Oh, sir, somebody is playing with me actually. So there is no network problem in my office, because I know the internet speed. I have checked it also. Okay.
Sir, please share the slide in a optimized mode. It might be helpful for us.
So it is in the optimized mode only. It is not in the actual mode. It is, I have already selected that option also. It has been optimized for the images and the videos, right? But no issue. Now you can see now. Dr. Ravi. Hello.
I'm able to see.
Okay, you are able to see now. So that's why I want to confirm it only. So you see how I have changed the bunny model into some hybrid kind of model, right? So this is also possible with the Meshmixer. So you can also add some other options. Suppose, for example, here you want to sorry, let me show you. For example, here also I want to keep the camel head. Right? I can change its position. Right? So in this way, you can easily make the models. You can easily, the mirror it. Right? You can, for example, you want to make this kind of complex model souvenir and new kind of models which are not available in the market, so you can easily make. This is the capability of the Meshmixer, right? STL editing, it allows the manipulation, it allows the the repairing. So then I can make it solid, right? Now it is solid. There is no separate solid part in this. This is single STL file now. Can you see? Right? So with this, I think it is enough for today. If you want to explore Meshmixer, FreeCAD more, you can ask if you have any query. Dr. Ravi,
Yes, sir.
it is all from my side, right?
Okay.
So this is the outcome of the lecture. You can see the model which we have prepared, right?
Yeah, definitely. It is. It seems wonderful that during the session we also came across some outcomes also. Yeah.
So participants,
So,
now you
yeah,
are
definitely. Thank you, Dr. Naren, for this wonderful discussion and entire in-depth discussion on the topic. So, dear participant, now Professor Naren is now open for queries. So, if any relevant queries are being there, so just please ask. So, rest you can also write in the chat box. Okay, so that I can read that, or Dr. Naren can also read it for you.
I
In
think
between,
one
so in
participant,
between
Baba
some
Saheb
queries were there.
English,
I'm
sir,
just going
please
to
repeat steps for delete part of the object. Delete part of
please
the
attend.
object. Okay. Let me show. Okay. I understood. Sir, delete.
Yeah, Dr. Naren, one query I would like to read. Yeah. Hello.
Okay. Let me repeat this.
Okay,
Professor
just
Ravi,
repeat.
let me
Okay.
repeat. Actually, what man is asking about the delete part is, for example, I have deleted this part only, right? This part. Can you see, Baba Saheb English? Can you see this? This deleted part, right? So under sculpt one, I have various options. Many brushes are there. So I will use this zipper edge. Okay, zipper edge. So zipper edge, I will increase its size. Oh, sorry. Actually, now my model has been changed. So it will. You can just go in the brushes, and you can use the zipper edge command. It will go do it for you, because my model now it is that much complex. So I can use many other options also along with it. So now it has just filled the gap. Okay, filled the gap, and some other part also can be smoothened by using other command. So I think now it is clear. How to make the scaffold structures in this. Okay, let me show you. Okay, scaffolding you want to. Okay, so in that case I have to take the simple part, otherwise it will. See, actually, it depends on the capability of the this. There is option Voronoi or something make pattern. Let me check. Where is this option? Right? Yeah, this one. This option is there, and here from I can use the. Can you see it? Dual is. Dual is. Let me check this dual
It is
is.
visible.
So this is your scaffold, kind of see, but it is not visible because your in that case I have to modify my. But you can see in the simulation as well because I have used this. You can see in the simulation itself. It is not taking right now because I have to change the mesh size. I have to increase the size of the mesh. Then only it will take. Otherwise, you can apply this on any kind of model. Okay, you have to change the. You just check the mesh size, and you can make the scaffold easily. Under the edit command, here we have the. You see this kind of shapes you will be able to make easily. In that case, you have to make a simple square or cube. Okay, you can apply this technique under the edit. Just make command, right? Under the edit, and now it is actually hanged. So you can just do it. Okay. Biomedical image like PET scan. PET scan. CT scan or PET scan? What? CT scan? I'm not getting your query. CT scan.
One query is there posted at 12.7. Here, sir, how to convert
12.7.
image like JPEG format into STL format?
See, JPG to STL, we have some sort of tools, right? Just type image to STL. You will find many websites. They are offering this particular facility or flexibility to convert your JPG to STL. Okay, and you can also find my research paper in my Google Scholar profile where we have developed an algorithm to convert JPG to STL file. But still, for application part, it is no need to go for algorithm and all. You just go to image to stl.com. You will find many things, right? You have to upload your STL file. Let me show you also. Otherwise, you will. Okay, stop. Okay, here. I think my screen already shared with you, no? So see here you will image to STL means JPG, and here you have STL. So once you upload the file, you can easily convert it and download. Is there anything? Yeah, actually I was taking the query regarding CT scan. Okay, let me. CT scan will also do. Yeah, actually CT scan again. You can use Mimic software for just convert your CT scan data into the CAD model. Then CAD model can be converted into the STL file, right? So this is how you can easily again that STL again you can repair with the help of Meshmixer. Is there any query from
No,
the
Dr.
participant?
But I feel that lot of discussion in between the sessions has already been done, and you have responded the asked queries.
Can any
So,
software
yeah,
check for
so
errors?
I think we can compile the session here.
Yeah, actually, I'm checking the chat box because I think if for more query, that's why I'm just checking.
Yeah, we can have some more queries if, but yeah, participants, you are open.
Janvi Manas, I think M button. Can you repeat, please? Yeah, actually, that.
Sir, it was very nice slide present. Will you share with us, sir?
regarding the STL.
Yeah, definitely, definitely, sir. Definitely, I always share my content with my participant. Otherwise, yeah, the whole lecture, will be waste of time because you will not get anything from this. After
Because you are
getting the
doing
content, you can repeat these steps.
No, मैंने बोलने को
Thank you.
मिला था लाके. Okay, sir, I'm asking for
Thank you.
PDF.
Thank you, sir.
वो ये रोज मांगता है.
Okay. Thank you. Ravi sir.
Yeah, Dr. Narendra, yes.
Yes, sir. Tell me, sir. Now what to do?
Yeah,
or we
please,
can
sir, we can
stop.
compile here. We are highly thankful to you for your valuable time and just take this time out of your very hectic schedule. I understand how the things are being there at NIT Jalandhar. The schedule is very tight and the people are very involving in just doing research and development and laboratory development as well. So yeah, I can
I
understand
think
all the
one
scenarios there.
message from Dr. Sushil Pandey.
Yeah.
He was with me long time back. I can see his comment also.
So
Thank you,
what
Dr.
I feel
Sushil.
that participants are highly delighted to have you here. They have interacted well. They have just cleared the various the basic queries, fundamentals to additive manufacturing, and how the STL repairment can be done using the softwares. So a lot of things you have covered. So we are highly thankful and grateful to have you, Professor Naren, here. Thank you so much, sir, for your valuable time. Thank you.
Thank you, Dr. Ravi. Thank you, participants, for
Yeah.
your time and patience listening me for 1 hour and 30 minutes.
We are also
Thank you.
planning one good physical mode workshop here in coming weeks. So definitely we will just interact physically here once you will visit our campus. We are having very
Dr.
beautiful
Ravi,
campus
recently we
here.
have got the FIST funding, in which also we are going to procure the metal 3D printer
Okay.
with the machining facility. So if any participant wants to explore that facility in future, so they can contact
Definitely.
me.
That's only the purpose
So,
of such interactive the platforms actually, so that we can interact with each other and such facilities at least can be known to our participants. There are professors, there are various researchers and scholars as well, so that they will be able to see the facilities as well as at NIT Kurukshetra, NIT Jalandhar, so that they can use out of that, they can learn something. So that's our outcome.
Sir, how
okay,
can
so
we
thank you all.
participate in that workshop? That's metal 3D printing.
Yes,
No,
Vinod.
that is not workshop, sir. Actually, Vinodji, let me explain what I'm saying. Soon we are going to procure that machine, right? And
Actually,
then we will organize such workshop, because right now we don't have facility.
Recently, actually, I'm again very happy to repeat that recently Dr. Naren and his wonderful team at NIT Jalandhar secured the funding of 2.9 crores from FIST, Government of India. So that recently they are just going to develop that laboratory at NITJ, and soon it will be functioning. Is it, Dr. Naren?
So yeah. We will install it, I think, within coming 6 months. So after that, we will try to organize one workshop on metal 3D printing, right?
Yeah.
So up to that time, we have to wait, right? Hands-on
So,
experience will be
Dr.
given.
Naren, one of the participant is asking for your official email address. I think you have shown it in the PPT, but maybe he was unable to see that. If possible, you can write, or you can also visit, Gaurav, you can also visit NIT Jalandhar website and go to the Department of Industrial and Production. So
I think
there
this
you can,
information nowadays is easily available. I think it's not
yeah, Gaurav
very difficult.
Khajuria is there, GCET Jammu.
Khajuraji, I have written in my chat box. Okay, you can
Yeah,
just
Gaurav, you can
note
see.
down.
Yes. Dr. Naren has already shared.
Thank you, sir. I'm from GCT Jammu, working in mechanical engineering department. So I'm working in 3D printing lab from last 2 years. We have FDM machine or SLA machine for student
Very
practical and on practical. I'm interested to visit NIT Jalandhar and meet you with to explore the
Sure.
knowledge about.
I have established here also additive manufacturing lab in NIT Jalandhar, so you can visit any time. Okay. I'm working on other
Thank you
project
so much.
also with ISRO and SERB, so you can also explore those things.
Okay, Gaurav,
thank you so much.
Vinod, thank you, Dr. Naren, so that it's a time to compile the session. Thank you so much.
Thank you so much. Thank you, Dr.